You are welcome to GMAT 41 Maths class. In this class today, we are going to explore further problems on indicial equation, this time leading to quadratic equation. If you take your mind back, in our previous class in mathematics, we treated indicial equations that lead to linear equation. Yeah, and we solved a couple of questions there where we established that these problems are simple. It's just for you to, apply your knowledge of the laws of indices, break them down, and you see how the equation, comes out simple as that. So we'll be giving attention to the type of indicial equation that leads to quadratic equation in our class today. And I hope that you're prepared for a wonderful class as usual. Meanwhile, I want to say that, for some times, not for some times, just last week anyway, the class was not consistent. The reason was because I wasn't feeling too strong, okay? Yeah, I was not too strong, although I was still doing some underground academic works. So it's my pleasure to still see you once again today, and we are going to move on straight on to deal with certain indicial equations that leads to quadratic equation. Most generally, how do we identify these types of question? How do we identify them? Now, whenever you're given indicial equation that will lead to a quadratic equation, especially quadratic equation that contains three terms, okay? The indicial equation will have three parts. Let's say A, B, C, okay? And then likely equal to 0. It's going to have three parts, three terms. Like you see here, A, B, C. That does not mean that in the question you'll be seeing A, B, C. No, that's not the meaning. This is one of the term, okay, and then this is another term, this is another term. So you have 1, 2, and 3. This term is usually the constant term, just like in normal quadratic equation. Just like in normal quadratic equation, this is the constant term. Okay, let's take it as a constant term. That term that does not contain the unknown you are looking for. That term that does not contain that, that quantity that you are looking for. Just usually a pure number, as the case might be. This A and B, they contain what you are looking for. They contain what you're looking for. Okay? Now, in these parts, usually you would have a power 2 term. Here, you will have a power 2 term. That is, in this part, you will have something, okay, a base with power 2. You will have a base with power 2. Again, this term will contain an unknown also. Power 2 term containing the unknown. Containing the unknown. Which means in this power 2 term, you expect to have the unknown in it. Then look at this second term. Okay, here you're going to have the unknown term here as well too, but this term would bear power 1. This term will bear power what? 1 term. Power 1 term containing the unknown. Containing the unknown. Containing the unknown. So this is generally how we identify an indicial equation leading to quadratic equation. So generally, as you see on the board, we have 3 terms in that equation. Most generally, we have 3 terms, okay? Proper quadratic equation is that contains 3 terms, right? Trinomial. The power 2 term, the power 1 term, and then the constant term. So this is how you are going to see questions on indicial equation that leads to what? Quadratic equation. This term is the power 2 term. But the power 2 term will contain the unknown. So also contain what? The unknown. But the unknown is not as simple as the type you used to see. Maybe if I give you normal quadratic equation as, okay, x squared plus 5x, let's say, plus 6. It will not really come in this form generally. Because when dealing with indicial equation that leads to quadratic equation, the unknown usually appears as a power. You want to take note, the unknown appears or exists in power form. The unknown exists in power form. Exists in power form. This is one thing you should take note of when dealing with indicial equation leading to quadratic equation. The unknown usually exists in what form? I say in power form, and that is usually what differentiates indicial equation leading to quadratic equation. That is what differentiates it from our normal quadratic. Our normal quadratic, the unknown appears as a base. Okay, but if you come to indicial equation, the unknown usually appears in power form. All right, but a particular base will bear the unknown as power, but that base is usually something else. Okay, it's usually a number. All right, I think I've given the whole idea of how the term in indicial equation leading to quadratic equation, the way in which you expect it to be. So we're going to pick questions and then solve. Once you join this class, please share the link to this class to your friends. Share the link to this class to your friend. And once, if you've not subscribed to this channel, you can click on the subscription icon and then turn on the notification bell. There is no time, okay? So you will not be missing out on our classes. Big math, what's the square root to? All right, TJ, you are funny. All right, square root to what? Please let us get to our question straight on. We have our first question. Remember, we are treating indicial equation leading to quadratic equation. I hope you can hear me from there. I hope you can hear me. If you cannot hear, let's assume that there is, a cut off in the transmission. You can let me know by typing. But I want to believe that you are following through. Let's go straight to question number 1. Question number 1. Let's see what we have. This class is going to be an interesting class, as always. Solve the equation. Solve the equation. So we have 5 to the power of 2x, and then minus 4, open bracket, 5 to the power of x plus 1, and then minus 125 equal to 0. I'd like to quickly say that the way we are going to approach this question generally may not look like the way some of you may meet it perhaps when you consult textbooks, or perhaps when you are being taught by another educator or your teacher at school. What GMAT 41 is going to do here is just to attack this question directly. There is a reason I'm saying this. When you're dealing with indicial equation leading to quadratic equation, usually there is a level you will reach, and then you'll be told, let you select another unknown to be equal to the term containing the unknown you are looking for. I like to really say clearly that, see, if a student understands how to solve quadratic equation, like the one I wrote earlier, x to the power of 2 plus 5x plus 6 equal to 0. In this case, we don't usually say, let this be equal to that. We don't say that. We don't say that. We just solve this problem straight, where first you multiply the coefficient of this term carrying square. In this case, 1. Multiply by the constant term, 6. And then you get 6. All right? Let me just quickly remind you. The coefficient here is 1. Multiply by this 6. 1 times 6 will give you, this is positive 6. Then you find two numbers, which if you multiply the two numbers, you are going to get 6. So let us assume that the two numbers are A and B. So it should be that if you multiply A times B, you get what? Plus 6. And then if you add A plus B, this one we say should give us this 6. And then A plus B should give us the 10, multiplying that raised to power 1 unknown. So 5. Okay, this A and B are the two numbers which you are to find. They must be factors of this multiplication you did. And now this multiplication is just the coefficient of x squared times a constant term. So you look for two numbers that are factors of this result. Two numbers that are factors of this result. This is also one among the many reasons why GMAETS 41 maintains that an excellent knowledge of mathematics is linked to excellent knowledge of multiplication table. And I always tell students, we have no choice. If you want to enjoy maths and calculation subjects, make sure that you are able to follow through your multiplication table, at least from 2 to 9 times table. Because to tell you the truth, it is multiplication table we are going to use in solving this. Is that okay? So what I'm trying to say in essence is, whenever we are solving quadratic equation of this form, we do not usually say, we don't say, let this be equal to that. We don't say that. Any of you that understand where I'm going to, perhaps you've seen questions on indicial equation before, I'm assuming, you would be figuring out what I am really pointing at. Because at the point in solving this question, you will hear, let maybe P be equal to that term containing the unknown. I'm not going to do that. You can actually solve that question directly, just like we solved these guys. You can do that without letting any unknown be equal to another unknown here. So let us see how we deal with this question. Solution. So what we're going to do is, first of all, identify the unknown term. Identify the what? Unknown term. And what is the unknown term? Here you can see the x term you have here and the x term you have here. However, if you look at this x term here, you notice that this is 5 raised to the power x plus 1, okay? Of course, this will be 5 raised to the power x times 5 raised to the power 1 using multiplication law of indices. So let me bring down the question. We have something like this. 5 to the power of x plus 1, and then minus 125 equal to 0. Please, there are foundations that we have established already, and I encourage you, if you have not taken those lessons, please go back to read part 1 and part 2 of this indicial equation, as in part 1, part 2, and part 3. Are you following? Take the lessons, because those foundations, we are not going to waste time talking much about them here. You see this term? 5 raised to the power x plus 1 was obtained from multiplication law of indices. This is actually 5 raised to the power x times 5 raised to the power 1. And 5 raised to the power 1 is 5. Which means that this term you are seeing here is simply, look at this term in bracket, is simply 5 to the power of x times 5. Okay, that is what you have here, because it is through multiplication law of indices on this term that we got this. Now, having said this, you see that this is a pure number. That pure number from that bracket, we multiply this 4 to give you 20, which means I can rewrite this term as you're seeing. Watch me now. 5 to the power of, there is something I want to do here. This guy is going to lead to quadratic equation. Why? Because if you come to this part, this is 5 raised to the power 2x. You have the power x here. That power x is multiplied by 2. It's multiplied by 2. That 2 becomes a focal point to us to begin to suspect that this guy is going to lead to quadratic equation, because of the fact that this unknown x is multiplied by 2. As long as this unknown part raised to power 2, are you following, right? This unknown part that is multiplied by power 2, as long as it does not really exist here anymore, that is that multiplier of 2. As long as it does not exist here, then you know certainly that this is going to be a quadratic equation. I take that again. We have power 2x here, and I told you that that 2 that is multiplying the unknown x is already an indicator to us that this is going to lead to quadratic equation, provided that this part that also contains the unknown x, provided that this one is not multiplied by 2, provided that this one is not multiplied by 2. If you look at this x here, this x is multiplied by invisible 1 here. So you notice that the power is like decreasing. Here, the power is 2. Here, the power is 1. And how do I get to know that? Power 2 because of these 2 multiplying this x. Power 1 because there is invisible 1 multiplying this x here. Take note, not this one. So there is a decrease in power, like you having x raised to power 2 plus x raised to power 1, in that order. And that is what makes us say that this is quadratic. I like to say this quickly. If this x here was multiplied by 2, assuming this x was multiplied by 2, this one here, please, it means that that equation will not lead. It will not. Yes, in 99.9% case, it will not give you quadratic equation. That one will likely be linear equation. Because this, if this guy has 2 multiplying it and this guy has 2 multiplying it, it means that this term and this term are like terms. That's the implication. But in this case, as long as this one is power 2 multiplying this x and then this is power 1 multiplying this x, definitely this will lead to quadratic. So from here, let me rewrite this term as 5 raised to power x. I'll put it in bracket. Then this power 2, I step it outside like this. Are you following, right? Then minus, I've already told you here you have 5 multiplying 5 raised to power x here. Look at the interpretation of what you have in the bracket. So that 5 that is multiplying this 5, that 5, which is this one here, will be multiplied by this 4, giving you 20 bracket. This will now be 5 to the power of x. Remember, like I said, there are certain foundations we are not going to overstress in this class, okay? Others that are necessary, I will talk about them. For example, I've just taken my time to explain why this will lead to quadratic. There is a way this question will be presented and it will not be quadratic. Quickly, like I explained, 5 to the power of 2x minus 4 bracket 5 to the power of 2x plus 1 and then minus 125 equal to 0. This guy will not be quadratic. The reason is because the term you have that contains the unknown, the coefficient of the unknown here and the coefficient of the unknown here, they are the same. Therefore, this guy will not be quadratic. Rather, it will give you what I would rather term an equation that will lead to linear equation, because this and this will be like terms. They'll be like terms if you simplify it out. Yeah, they'll be like terms. Okay, so let's move on. I'll come over here and then I put 125 equal to 0. Now you see clear that we have 3 terms here. This is one of the term, this is another term, and this is another term. Just like what I told you about A, B, C, you know. This is the constant term because it does not contain the unknown. It doesn't. This term is the raised to power 2 term. You can see it. And this one is the raised to power 1 term. Now observe this equation that we have here on the board. The unknown part is that term that has 5 raised to power x. So we have 5 raised to power x here. We have 5 raised to power x here. So this is a quadratic equation in the base 5 raised to power x. This is a quadratic equation in the base, or in the term rather, a quadratic equation in the unknown term 5 raised to power x. I repeat, this is a quadratic equation in the unknown term, 5 raised to power x. You see, this whole thing you are seeing here now is just like somebody giving you x raised to power 2 minus 20x minus 125 equal to 0, and you're asked to factorize. It is still the same as somebody giving you something like maybe this whole term in bracket replaced with p raised to power 2 minus 20p minus 125 equal to 0, and you solve the quadratic equation. It is at this point usually that in textbooks and maybe many other educators may come in and say, let's, you know, since you have 5 raised to power x here and you still have 5 raised to power x here, is a common term. But these two guys are not like terms. They are not like terms. They are not. They are not like terms because their powers are different. This is power 2. This is power 1. In polynomial, like terms of polynomial are judged or identified by the power of the terms. Are you following? So these guys are not like terms. They are not. The only thing is that they contain common term. And the common term is the unknown term, which is 5 raised to power x. But their powers are different. Their powers are what? Different. So since the term you have here, the unknown term, you also have it here. One can say let p be equal to 5 raised to power x, so that this equation will now become p squared minus 20p minus 125 equal to 0. You replace p for the unknown term. But I'm not going to do that. For God's sake, we should grow beyond all this level. We can solve this thing directly using the direct knowledge of what we do in quadratic equation. Yeah, like I said already, the unknown term is 5 raised to power x. So what you're going to do is to solve this equation for 5 raised to power x. And how do you solve it? It's simple. Take note of the following coefficients. Coefficient of the unknown term. Here, the coefficient of the unknown term, 5 raised to power x. The coefficient is invisible 1. Take note of it. Invisible what? 1. Come here, the coefficient of 5 raised to power x. The coefficient of 5 raised to power x here is minus 20. Like here now you have 1, like I said, the coefficient of this term. The coefficient of this term is minus 20. And then the last term, you have minus 125. Minus 125. Remember, like I told you, A, B, and C. So all you are just to do here is simple. The coefficient of this guy raised to power 2, remember, that is what you are going to use in multiplying the constant term. If you do 1 times 25, for example, 1 times minus 125, you are going to get minus 125. So all you have to do is to find 2 numbers that are factors of minus 125. Remember, the unknown term here is 5 raised to power x. So what we are going to do here is to solve and get the value of 5 raised to power x. And then from that value, we can now get the value of x. Of course, because this is a quadratic equation, we expect to get 2 values of 5 raised to power x. But these are the numbers you are going to use in solving this question. Very simple as that. Go ahead and use this coefficient of this guy carrying power 2. Use it to multiply the constant term. Look at it. You work all of this. This is the network of your brain now from here. 1 times minus 125 will give you minus 125. Look for 2 numbers, which if you multiply, you get minus 125. These numbers must be factors. They must be factors of 125. And then those numbers, you must add them. When you add them, it must give you minus 20. It must give you minus 20. So the question is, what are these 2 numbers? An excellent knowledge of multiplication, which will lead you into factors of numbers, will tell you that the factors of 125, which if you add, you get 20, will be 25 and 5. 25 and 5 will solve the problem for us. 25 and 5 will solve this question for us, okay? But you want to work on their signs, because if you multiply this 25 and 5, it is expected to give you minus 125. And if you add them, it is expected to give you minus 20. So what will be the sign of this 25 and 5 that will achieve that? You'll agree with me that 25 will be a minus and 5 will be a plus. Minus 25 times plus 5 will give you minus 125. And then minus 25 plus 5. Simply minus 25 plus 5 will give you minus 20. You have solved this. It means that 5 raised to power of x would definitely be equal to something here. Now, having explained all of this to you, I'm taking my time to explain this first question. So like I said, there is something that most textbook, the way it will present, say let's so be equal to 5 raised to power x and another thing. I don't like doing that. I have video lessons where I did that. Under our playlist in Math 101, you can search for that, okay? Yeah, I'm not going to do that here. Let's approach it directly. We have gotten the factors that will do the work for us, minus 25 and what? Plus 5. We solve this question. Like I said, I just brought this thing out for you so that you know what will now be your focus by the time you get to this point. We don't really need to write this thing out. They are not necessary. We're seeing them here. We're seeing them. We're seeing them. So why bring them down? It's not necessary. Okay, factors that we solve this problem. Factors. I'll go straight. The factors we said are minus 25 and plus 5. Now, what do you do from here? Anytime you get factors of a quadratic equation, I repeat, anytime you get factors of a quadratic equation, change their signs. Change their signs and divide each of them by the coefficient of that term carrying power 2. The coefficient of the term bearing power 2 is 1. So to get the root of this equation, the solution, we are going to change this sign here. This is minus. If you change it, you get plus 25. And we'll change this one. This is plus. If you change it, you get minus 25. If you do that, divide each of them by this coefficient, 1. If this guy were to be 2, you'll be dividing each of them by 2. So we'll still have other questions to deal with. From here, therefore, we can say the value of 5 raised to power x the value of 5 raised to power x is equal to, you come to one of the factors, like I say, change the sign. If you change this sign, you are going to get 25. Divided by what? 1. Let me just show you, but I'll still wipe it. Any 10 divided by 1 will give you that 10. So this is equal to 25 directly. From here, it implies that 5 raised to power x will be equal to, you come to 25, you get 5 raised to power 2. You now solve it simply as linear equation. You solve it as indicial equation that leads to linear equation. Very simple. We've done this in our previous class. From here, therefore, you find out that one of the value of x equates their powers since the bases are what? The same. So one of the value of x is what? 2. Or, the alternative value, 5 raised to power x will be equal to, you come to the second factor, change the sign. This is plus 5. If you change that plus, you get minus 5. So it's going to be minus 5 divided by the coefficient here, which is 1. If you divide any term by 1, you still get that term. So I'll wipe this. This is simply minus 5. You see this guy? There is no way, I repeat, there is no way you can express plus 5 to become minus 5. And so there is no way you can have the same base here. This is minus 5. Take note, it is not just 5. If what we had there was just positive 5, 5 and 5, good. We could have just said the bases are the same, so equate the word powers. Are you getting me? In this case, the bases are not the same, and this minus is a big problem for us. There is no way you can express both sides. Are you following, right? To have the same, maybe minus 5 is not done. So in problems like this, you can say this one implies no solution. Implies what? No solution. This cannot give you any result. And in fact, converting this to logarithm can tell us truly that this guy has no result. Because you can actually convert this basis to logarithm. But if you work on it, you'll notice that this would be an indeterminate term. You can't solve it. For example, if I have 5 to the power of x equal to minus 5, this whole thing we did here to solve and obtain this, what we did was actually at this point, we took log of 5 raised to power x base 5, and then log of 5 raised to power 2 base 5. I've explained this in, I think, the last class. So with the logs being taken, log of 5 base 5 will give you 1. So that leaves you with x. Log of 5 base 5 will give you 1. It leaves with 2. Therefore, x will now be equal to what? 2. As simple as that. But look at this term. If I decide to introduce log there, log of 5 to the power of x base 5 to be equal to log of minus 5 base 5. Log of a negative number does not exist. The least log you can get is log 1. Log 1, are you getting, which is 0. You can't get log of a number less than 1. Minus 5 is less than 1. So if you have to use calculator and maybe evaluate this, you would get math error. It is an indeterminate term. It doesn't exist. So the second guy does not produce any solution for us. Are you following? The second value of this root of the equation does not produce any result for us. Remember, the roots of the equation are 25 and minus 5. How do you obtain the 25 and minus 5? Go to the factors that solve this problem. Change the signs of the factors and divide each of them by the coefficient of the term bearing square. With this, you get directly the value of the unknown term. And the unknown term is 5 raised to power x. So the first value of 5 raised to power x is 25. From there, you solve for x by breaking down this 25 to the same base 5, which is what I did here. If you solve, the bases are the same. Therefore, you equate the powers. You can cancel out the base. You can just drop the bases since they are the same. X is 2. The second term is this. So, assuming that this minus was not there, that you have 5 raised to power x equal to 5, we could have just smiled and say, okay, the bases are the same, so you equate the powers. And the powers will be x equal to 1, so that the solutions will now be 2 and 1. But of course, in this case, the second root does not produce any solution. So we have only one solution to this equation, which is x equal to 2. So I've taken my time to expose many of your eyes to, something in solving quadratic equation. So that next time you don't go punishing yourself to say, let this be equal to whatever at this level. It's not necessary. Except if your examiner so wish to punish you, maybe they give you a procedure to follow where they assume that thing, then you can follow through. But if they do not, you can solve directly. We're going to take question number 2. Let me check the network situation. Let me check the network situation. All right. I think we are still on. Having taken my time to explain this first question, we'll be fast in solving the second question. And I'm going to wipe this. Don't mind the lighting situation today. I actually had to do some connections and a power holding company, or how do they call them? EEDC, Enugu Electricity, Guinea. They can mess us up, a lot of time. We don't trust this power production company here. Yeah, that's the truth. Until they repent. So I'm just managing a lighting system, right? So support this channel. Imagine you support this channel, and of course, we can be able to provide all the things we need to make our class, and a sweet one as always. The lighting system. I'm talking about. Let's get solar now, right? It's not bad. Besides, I am giving to the nation, right? So you can support this channel. You can send GMAETS 41 super chats, super thanks. Below each of our video, you will see the thanks. The thanks icon. Just click on it, and then support GMAETS 41 with whatever that is convenient for you. That is one-time support. Okay, you may decide to support us monthly. And how do you do that? Just become channel members. Below our videos also, you would see membership, join tab. You see join tab. If you click on the join tab, you can join us on the platinum or on the diamond level. That one is a monthly support. And if you join GMAETS 41 on those levels, the higher the level you join, the more benefits you can also get. So as you support the channel, we work together, and of course, all the things I need to ensure that I deliver effective works to your friends, we'll continue to do that. I hope you understand this, right? Good. So how about you discuss this with your teacher? Okay, let us assume that you are offering further mathematics if you're in Nigeria, or you are offering advanced maths, A-level maths. How about you discuss this with your teacher, with your lecturer? Because most educators, most teachers, most lecturers, perhaps because of the way textbooks present this, whenever they get to this level, there is always this assumption that is being made. Maybe we say P be equal to 5 raised to the power x. They will come to this, the unknown term, they'll remove it and then fix P and solve for P. At the end, they'll still go back and say, recall. Remember, we assumed P to be equal to 5 raised to the power x. But now this is one of the values of P we got, which of course, if they do that, the values of P they will get for this question, or the value of whatever they call the unknown term, will be 25 and minus 5. So they'll now return it. Okay, since we assume P to be equal to 5 raised to the power x, it means that 5 raised to the power x is equal to, in place of P, they'll fix the value, which is 25, and then solve for x. All of those things are just stressful things. They aren't necessary. So how about you discuss them? So what if I go directly like this? Ma, what if I solve this thing directly? I hope you're not going to penalize me. Of course, no teacher, no lecturer has the right to penalize any student who decides not to assume that thing. Because I see no reason why we solve this thing directly in quadratic equation straight on as per what we know about quadratic. And then we'll come here and we'll be assuming that it's not necessary. Coefficient of the terms in quadratic equation together with the constant term are the things you need to solve any quadratic equation to get the unknown term. So we mustn't assume anything for this unknown term. It's not necessary. I'm not saying it is wrong that we do it. I'm saying it is not necessary. I had also done this in previous videos of mine. I assume that. But of course, just because we have to do it, I'm saying it's not necessary, okay? Let's move on to the next question, number 2. Question number 2. Let's see what we've got. Remember, this is a 1 hour 30 minutes class. I'm going to speed up now because I've taken my time to explain all of this in this First question. Whatever we do else is just repetition. It's just questions written in different form. It's the same process. So we are not going to waste time again. Okay? If you have any question, you can drop in the comment section. In the comment box, I will attempt to read. Let me copy this question on the board. Question number 2. Solve the equation 2 exponential 2 bracket x plus 1, and then minus 5 exponential x plus 1, and then plus 3 equal to 0. So that's the second question we are to solve. Okay? And this is quite simple. If you look at, you can observe and then determine the unknown term. That term that contains the unknown. And you can see that here, this exponential bearing this power x plus 1. If you observe very well, you will agree with me that this exponential x plus 1, because this e is an exponential term, pronounced exponential function. So this exponential to the power of x plus 1 also appeared here. Now look at what is multiplying that power x plus 1. Here we have 2 multiplying it. We have 2 multiplying this unknown power. That becomes a focal point for us to begin to suspect that this guy may lead to quadratic equation. To conclude that yes, it is going to be quadratic, we'll now look at that same exponential term with the power x plus 1 and check the coefficient. If I enclose this in bracket x plus 1, you will see clearly that the coefficient is what? Invisible 1 here. So it's as if the power of that exponential term is reducing. Here it is power 2. Here is power 1. Just like somebody giving you 2x raised to power 2 minus 5x and then plus 3 equal to 0 to solve. I repeat, imagine somebody giving you 2x raised to power 2 minus 5x and then plus 3 equal to 0. Where this x is representing all this exponential x plus 1. Look at it again, x. Same exponential x plus 1. The only difference is that this x is power 2 because of this guy. And this x is power 1 because the multiplier of this x plus 1 here, the coefficient is what? 1 as well too. And so we can play with that question easily. Nothing is there. So in this case, we'll be solving for the unknown term exponential x plus 1. Meanwhile, let me check the comment section in case anyone has a question here. All right. So no question yet, meaning that you are actually following what we are doing here. Let me see, can adjust the light a bit. So let's see. All right, solution. So we have 2 exponential 2 bracket x plus 1, and then minus 5 exponential x plus 1 plus 3 equal to 0. That is a question given to me. See, why punishing myself here? How about I decide to shift, this power 2, always write it after the unknown alphabet. And so you now see that it's like the unknown term raised to power 2 in that order. Anyway, let me just proceed. Let's rewrite. This is the same as 2 times exponential x plus 1 and then power 2 here. You following, right? This whole thing. You now have power 2. Then minus 5 exponential x plus 1, then plus 3 equal to 0. From here, someone can decide to say, okay, let k be equal to this exponential x plus 1. You see that you have this exponential x plus 1 here. You also have this exponential x plus 1 here. The only difference is that the power of this exponential x plus 1 term here is 2. But here, the power of this exponential x plus 1 term is 1. So it becomes quadratic with the power reducing from 2 to 1 in that order. In fact, we might stubbornly decide to say, okay, let these 3 be written as 3 exponential x plus 1, then power 0. So you see how this quadratic equation is actually a polynomial. Polynomial is an expression written such that the degree, all those powers are called degree, the powers of the unknown will be reducing in certain order. That's just it. Here, the exponential term of x plus 1, is power 1. Here, it is power 2. This constant 3 that does not contain any exponential term actually has an invisible exponential term written like this. Because this whole term raised to power 0 will give you 1. An exponential term to power 0. Because this bracket times 0 is 1. Right? Sorry, this bracket times 0 is 0. And then exponential 0 will give you 1. 1 times 3 still returns you back to this 3. So, you see, that's just the whole thing, Very simple concept. Nothing is difficult there. So from there, what do I do? Simply, let this be that is not necessary. We can solve this directly. We have the coefficient of interest that we need to use in solving this problem. The only thing is that the unknown term is the exponential x plus 1. That is what we are solving for. Just go straight and find the factors that can solve this problem. Change their signs and divide by the coefficient of the guy bearing the square. That is, divide by the coefficient of this whole thing. And the coefficient is what? 2. And that's it. Equate the exponential x plus 1 to your final roots of the equation. Please let us play with it and see. Directly, we are trying to get the factors that we solve this question. Now, how do I solve the problem? Look at the coefficients and the constants. Use the coefficient of the raised to power 2 term. Use it to multiply the constant. So 2 times plus 3. 2 times plus 3 will give you plus 6. All of these, you now work it by activating the network of your brain. Nothing is there. 2 times plus 3 will give you what? Plus 6. So find 2 factors of plus 6. 2 numbers which if you multiply them, you get plus 6. But the 2 numbers must also satisfy the condition that if you add them, you must get this middle term that is multiplying the raised to power 1 term. Okay? So 2 numbers which if you multiply, you get plus 6, then you add and get minus what? 5. And what are the numbers? Multiplication is the key. Please don't play with multiplication. In GMAETS 41 basic class channel, I'm actually carrying out an adventure where I'm solving different types of questions in maths, explaining and exposing, as well as encouraging scholars, to adopt the power of multiplication and the brain developing effect of multiplication. There are so many things, topics in maths, in calculation that are dependent on multiplication. Just learn multiplication table at heart from 2 to 9 times table, and that's all. To now become easy for you to understand maths and calculation subjects or courses when you are being taught. The factors that will do that for us are minus 2 and minus 3. If you multiply minus 2 times minus 3, you get plus 6. Minus times minus changes to plus. 2 times 3, 6. And if you add minus 2 plus minus 3, you get minus 2 minus 3, which will be equal to minus 5. So these are the factors. From here, the root of the equation will now be what? The roots, to get the roots of the equation, which are now the values of exponential x plus 1. In fact, should I leave it as roots? The roots are the values of this exponential x plus 1. Exponential x plus 1. Because that's the unknown term. And how do you get the roots? I've told you, change the signs of this guy. If you change their signs, divide them by the coefficient of the term bearing power 2. That's it. So like this one now, the root or the final answer for this will be positive 1 plus 1, which means exponential x plus 1 will be equal to 1. And then you solve for x there. Then the second value coming here, if you change this sign, you're going to get plus 3 divided by 2. You get the root of the equation, which is 3 over 2. Meaning that exponential x plus 1 is equal to 3 over 2. You solve for that x if it is solvable. Just say. Okay, now let me just say, root of the equation will now be, change this sign, you get plus 2. Divided by this 2, which is equal to 1. And come here, change this sign, you get plus 3. Divided by this coefficient. 3 over 2 is not a whole number. In decimal fraction, it is 1.5, right? Yeah. In mixed fraction, one whole number, 1 over 2. But it's not ideal getting the result in that form. You can just leave it like this. These values you are seeing, these roots of the equation, right? 1 and 3 over 2. They are the solutions of exponential x plus 1, which means that the unknown term exponential x plus 1 is equal to 1. You solve and obtain the value of x here. Let's solve for it. After that, we do OR. Does that make sense? Okay, so solving for this, if you come to this term, all I have to do now is to ask myself, what can I do to get both sides of the equation in the same base? This is e, exponential. This is 1. So how can I convert this 1 to this exponential base? And it's simple. Take note of this now if you had not known before. Exponential 0, e raised to power 0 is 1. You can confirm that from your calculator. So this means that we have exponential x plus 1 equal to exponential 0. This exponential 0 is 1. A 10 raised to power 0 is 1. You know that. The bases are the same now. You want to cancel, you cancel, the choice is yours. There is no mathematical rule broken. You want to say, okay, the bases are the same, so the powers must also be the same. Equate the powers, the choice is yours. So we are saying that x plus 1 is equal to 0. Therefore, one of the value of x is minus 1. Here, one of the value of x is minus 1. If you fix minus 1 here and you simplify, you'll find out that all this term on the left-hand side will give you 0, which balances the right-hand side. So the equation is satisfied with x equal to minus 1. How about you try that yourself? Or we go for the second value. The unknown term exponential x plus 1 equal to 3 over 2. 3 over 2 is 1.5, I said, or 1 whole number 1 over 2. There is no way you can convert 3 over 2 to the exponential base. It's not done. It is not done. Most generally, in cases like this, we conclude no solution. In indicial equation, whenever the bases cannot be expressed in the same term, we usually conclude that there is no solution. It is not as if we cannot do some mathematical, stops. It's not as if we can't follow through some mathematical procedure to get the answer. Most often we can. But of course, that does not include the previous one we solved, where we had minus 5. That minus, there is no way you can introduce log to get your result. It's not done. Log of a negative number, I told you, it doesn't exist. Okay? But if it is a positive number, just like this, but you cannot express both sides in the same base, in the most severe case, an examiner may allow you to introduce log in that case. Like I said, most generally, let's assume you are sitting for an exam where calculator is not allowed. The conclusion you usually make is that there is no solution. But I don't want to do that. No solution simply because the basis on both sides of the equation cannot be expressed to be the same. You can't do that. They can answer, okay, no solution. But it doesn't mean that there is no real mathematical solution that there is. So for this particular guy, I won't make that conclusion. I will not. I would have us solve and get the result. And how do we do that? All we have to do is to find a way to remove this exponential. So we'll not be dealing with pure numbers. That makes sense. Okay, let's see. To remove exponential, you take natural logarithm. Natural logarithm is ln. Ln is log to base e. Ln, the same as log to base e. So whenever you hear of that function ln, it shares the same properties as log. So all the properties of logarithms, you apply it here. Now after indices, we'll be talking about logarithm. Are you getting me right? Logarithms without table. So I am going to take ln of both sides. I'll write ln of exponential x plus 1 will be equal to ln of 3 over 2. Ln 3 over 2 is a number, but I don't know the answer. I don't know the answer. You can evaluate it with your machine, calculator. Now, if it is ln 1 is 0, at least I know the answer of that one, because it's the same as log 1. Now, what does ln do to exponential? Ln removes exponential from a term. You take ln exponential, both the ln and the exponential will go off. It's just like taking square. of a term that has square root, or taking square root of a term that has square, or taking sine inverse of a term that has sine. That's what happens here. The same thing, if you have ln, I want to remove the ln, you take exponential. So if you're not aware of that, I have told you. So from here, the exponential and the ln will disappear. You'll be left with x plus 1, and then that will be equal to ln 3 over 2. And from here, the value of x will simply be equal to ln 3 over 2 minus 1. That is the second value of x. Can conclude therefore x equal to, the first value is minus 1, or ln 3 over 2 minus 1. You see, this second result is a bit complex. That is why most cases examiners will not be really interested in having that there. Because if you are to get a single value of x, it will require you to use calculator to evaluate. And in most cases, our CBT exams now, as most exams are really moving into, you're not allowed to really use calculator. The calculator in the system does not have much of all these functions. So in reality, the main value of x in this equation is minus 1. And you can prove it. Come over to this question, fix minus 1 here. You're going to have minus 1 plus 1, which will give you 0. 0 times 2 will give you 0. Exponential 0 will give you 1. 1 times 2, this whole term will now produce 2. Come to this, fix minus 1. Minus 1 plus 1 is 0. Exponential 0 is 1. 1 times minus 5 will give you minus 5. So this whole term is minus 5. We now have 2 minus 5. Then this is plus 3. 2 minus 5 will give you minus 3. Minus 3 plus 3 is equal to 0. So the equation is satisfied. You may wish to try this one. Okay? You still get the same result. Nothing is there. Come over here and then fix ln 3 over 2. There are certain principles you will apply to get the result, but I'm not going to waste my time on that for now. I'm done solving this question. I hope you understood it, right? Let me check the network situation as usual, and we are moving on. We are almost 1 hour gone. This is 50 something minutes, approximately 53 minutes. So we'll be moving on to the third question. I hope this did not cut off. Let me wipe this. So this is the two final possible answers to this guy. Okay, let me check once again the camera, the left side to be sure, right, it showed. It's there. So we'll be moving on to question number 3. So you see the way I am simplifying indicial equation leading to quadratic. It's quite simple, nothing is there, okay? Let's look at the third question. I'll be wiping this. Remember, at the end of this class, a copy of this live video will be made available. This live class, a copy of it will be made available, so you can still check back. If you have not copied the notes, you can check back to copy the notes. When you check back, you can still rewatch, you can take the class again. If there is a point you missed out, as I am live like this, if there's any point you missed out, by the time you replay, if you come back, you can rewatch and pause at that point to pay attention to what I've said. And you can always also make your own short summary notes as a guide from the points, the key points I'm hitting out for you, Very important. Let us look at this next question. The next question we have to solve the equation. Solving the equation simply means find the value of the unknown also. Solve the equation 3 to the power of 2x minus 1, and then minus 12, then 0.3, that is 12.3x. Please, this is multiplication sign. This point, when it is used here under this indicial equation stuff, it represents multiplication, okay? It's 12 times 3 raised to the power x, and then plus 81 equal to 0. This is what we have here. Solution. I think that's a question. Yep, that's a question. 3 raised to the power of 2x minus 1, and then minus 12 times 3 to the power of x, then plus 81 equal to 0. From what I've explained so far, you see, technically this problem on the board is as good as 1 plus 1. And one can tell that this will lead to quadratic equation clearly because here, the unknown x has 2 multiplying that part. Are you following? Although we have power minus 1 here, but there is no big deal. Remember, this term is obtained from division law of indices. Look at this whole term. It is the same as 3 to the power of 2x divided by 3 to the power of 1. It is this term that we actually used in getting this, using division law of indices. Otherwise, you could still decide to write it as 3 to the power of 2x times 3 to the power of minus 1, this term. And then use multiplication law of indices, pick one of the common bases and then add the powers. But if you interpret this, you know this is 1 over 3 using reciprocal law of indices. All these things, we've established them already. And if you apply reciprocal law, this term will return you back to this one. So this term you're seeing is actually 3 to the power of 2x divided by 3. Let's move. Let us solve this question. This is a quadratic equation, very clear. You have power 2x here, 2 times the unknown. You still have the same unknown appearing at the unknown term, 3 to the power of x. But you notice that the coefficient here now is 1. So it's as if the power is reducing from power 2 to power 1. And then here, you still stubbornly want to show your times 3 raised to power anything. This is actually 81 times 3 to the power of x in bracket to power 0. But don't punish yourself with this. It's a constant time, so let's just move on. I'm going to rewrite now, solving straight. This question is the same as 3. And then I'll write my x first, shift this to this way. So it becomes the unknown term 3 raised to power x, and then power 2 here. I'm dividing it by 3. I've interpreted this for you already. This power minus 1 is the same as 3 to the power of minus 1. Are you following? Which will become over 3. Then minus 12, then bracket 3 to the power of x plus 81 equal to 0. Now, look at this over 3. Let me still rewrite it in another form for you to see. I don't want us to waste time here. This over 3, if you divide, let's say I have 5 over 3, this is the same as 1 over 3 times 5, which can still write as 1 over 3 bracket 5. Okay, so can we actually write that here? Yes, we can. This is actually something like 1 over 3 bracket this whole time. You see, 1 over 3. From the fact that this term you are seeing here is 3 raised to the power 2x times 3 raised to the power minus 1. And that 3 raised to the power minus 1, by reciprocal law, I have told you is the same as 1 over 3. Look at it here. So that this 1 over 3 becomes a coefficient of this unknown term that is raised to power 2. Now we have gotten our proper quadratic equation, where the quadratic equation contains the unknown term 3 to the power of x. It's just like somebody giving you 1 over 3 p raised to the power 2 minus 12p plus 81 equal to 0 to solve. Now, if you like, you can clear the fractions. You can clear the fraction rather by using the LCM 3 to multiply all the terms, so that this will become p squared minus 36p plus 3 times this is going to give you what? 243 equal to 0, and then you solve. But all of these are waste of time. Go and learn your multiplication table at heart. Memorize your multiplication table at heart from 2 to 9 times table. I released a video recently about it, I think that's last week, emphasizing and encouraging the importance of scholars at all levels of education having their multiplication table at heart. You see, that basic operation multiplication is very important. I keep talking about it. Don't joke with it. See, your ability to even memorize that table from 2 to 9 times table alone, your ability to memorize, to cram it, wrong with it, no, we practiced it. And it's very important. And to our dear teachers out there, once a child learns that multiplication table at heart, don't just end it at, okay, the child learned it and is just singing it. Start exposing the child to a lot of applications of multiplication, starting with how division depends on multiplication, and then boom, you start moving to other applications in terms of other topics. Okay, now let us move on. Don't have time. So from here, these are the terms of interest to us, the coefficient, and then the constant term. We're going to solve the equation and then obtain the value of 3 raised to the power x. From it, we can now get the value of x. Now, as usual, what do? Use the coefficient of this term carrying power 2, which is 1 over 3. Use it to multiply this 81. You see, somebody might decide to say, let me clear fraction by using the LCM 3 to multiply all the numerators, like I said. But doing that, you remember I showed you something here. It will become even much more, the numbers will increase, making it a bit cumbersome, complex to factorize. It is best, works 3. There is no big deal there. Use 1 over 3 to multiply plus 81. And of course, 1 over 3 times 81 is going to give you what? 27. Is that not so? You're going to get plus 27, which if you add them, must be equal to minus 12. So which two numbers will do that? And you'll be thinking of the factors 9 and 3. Yes, 9 and 3 will do the work. So let me just write here. I'll wipe this guy off. Just leaving it for you to see. The factors to solve these problems are what? 9 and 3. But what are the signs of this 9 and 3? Because of this minus 12, right? And this is plus 27. The 9 and 3 is going to be minus 9 minus 3. Am I communicating? Now, minus 9 minus 3, if you multiply them, you get plus 27. And then minus 9 plus minus 3, if you add, you get minus 12. So the factors that can solve this problem is minus 3 and minus 9. The root of the equation now is simply change this sign 3 and divide it by 1 over 3. Because you must divide by this coefficient of the term carrying power 2. And it's simple, say, if you have change this sign 3 divided by 1 over 3, mathematically, if you come to division of fraction, this 3 will go up and multiply this numerator, so you'll be getting what? 9. Come here, change this sign. If you change this sign, you get plus 9, divided by 1 over 3, this coefficient. So again, this 3 goes up, and you get what? 27. So that the root of the equation here to solve this problem is 9 and what? 27. 9 and 27 are the roots of this equation. They are the solutions of 3 to the power of x. And from there, you can get the two possible values of x. We simplify concepts on this channel. If you are yet to subscribe, right away as I'm talking about a subscription, click on the subscription icon right away. Then turn on your notification bell. If you subscribe, click on the notification bell after that. You'll see a menu pop up. Click on all, select all there. So at any time I come on live or GMAT 41 uploads any pre-recorded lesson, you will be personally notified firsthand by YouTube, so you can come and learn. We have a timetable guiding us. Mondays from 8 p.m. Nigerian time or West African time. Sometimes I come on 8:30 depending on the whole situation that day. That is why you have to subscribe and turn on notification by selecting all, so that if I don't come on live exactly at 8 o'clock a.m. or 8 o'clock p.m. or 8:15 p.m., whenever I come on between that 8 o'clock p.m. to 8:30 p.m., you will immediately be notified. So you prepare within that time, okay? So let us go. The value of 3 raised to the power x will now be equal to, we go, come to these factors, change this sign, you get plus 3. Divide that plus 3 by 1 over 3. I've told you that the over 3 will climb to multiply the numerator 3. So you get what? 9. In fact, let me show you. It's going to be 3 divided by 1 over 3, which is equal to what? 9. Or you come here, change this sign, or 3 raised to the power x is equal to, change this sign, you're going to get 9, divide it by 1 over 3, which eventually gives you what? 27. Now you have the two values of 3 raised to the power x, which are 3 raised to the power x equal to 9 or 3 raised to the power x equal to 27. Solve for x from there. From this part, 3 raised to the power x is equal to 9. Break down 9 to base 3, which is 3 raised to the power 2. That tells you that bases are equal, so drop the bases, equate the power simply. X is equal to what? 2. This is one of the results of x. Or you come here, this is 3 raised to the power what? X equal to 27. Break down that 27 to base 3 because it is possible. 27 is the same as 3 to the power of 3. Bases are the same, so equate the powers. Therefore, x is equal to what? 3. The two possible values of x for this indicial equation are 2. There you get what? 4 minus 1, 3. 3 raised to the power 3, 27. Come here, fix 3 here, you get 27. 27 times 12, work it out. And let's simplify. The equation will do what? Balance. Let me conclude that here. Therefore, x is equal to 2 or 3. These are the two values. Answer. So guys, I hope you enjoyed this class. This is where we are going to be calling it a short. Wow, the network interfered terribly. I don't know if what I solved here on the board showed. I just came and found out that this was reconnecting. Can someone type, if need be, can someone indicate if you followed the solution to this question number 3? This is question number 3, not number 2. This is question 3, we've solved 2 already. I found out that, the network interfered somehow. Did you follow this last solution? Did you follow this last solution? Okay, although it is here on the board and we've just been repeating the same thing over and over again. All the secrets you need about indicial equation leading to quadratic equation, I've exposed them full time. I've exposed them. So what we did there was just simple, multiply 1 over 3 by this constant term as usual. We got 27 because 1 over 3 times 81 will be 81 divided by 3, which is 27. Then we found two numbers which are factors of 27. Add them, you get minus 12. The numbers which are the factors to solve this problem are minus 3 and minus 9. As usual, to get the roots of the equation, which are the values of 3 raised to the power x, the unknown term, all you have to do, come to the factors, change their signs, and divide by the coefficient of 1 over 3. Look at it. The value of 3 raised to the power x will now be equal to 3. Come in here, change this minus 3, get plus 3. Look at it, and divide by 1 over 3. Solving it, you get 9. Do same for this second factor. Change this sign, minus 9. You get plus 9. Look at it. Divide it by the coefficient of the term carrying power 2, which is 1 over 3. This 3 goes up, multiplies 9, you get 27, which means the second value of 3 raised to the power x is 27. From each of them, this one, 3 raised to the power x equal to 9, solve and get the value of x. To do that, 3 raised to the power x equal to 9, break down 9 to base 2. 9 is 3 raised to the power 2. The bases are the same, so you equate their powers. Let me check the network again. Okay, it is there. Equate their powers. And that is how we got x equal to 2. Then in the second possible values, we have 3 raised to the power x equal to 27. Break down 27 to base 3, which is 3 raised to the power 3. Bases are the same. You keep them off. If you want to cancel, you cancel. The choice is yours. Or simply equate the powers. That's it. Once the bases are the same. So x equal to 3. So the two possible values of x that solves this question are x equal to 2 and, or you use or, x equal to 3. Okay, I think I meant to use and because both of them satisfies the equation, and 3. So like I said, that's it. With this principle, what we have done here, let me see if I can boost this network a bit. The network really interfered in this last question, but all the same, I've done the job there. And with this third question, like I said, this is where we call the class a short. We are still 1 hour, within 1 hour, 10 minutes or so into the game. We still have like 20 minutes or so, but the class is going to come to an end, for we have covered what we are meant to cover in indicial equation leading to quadratic equation. I'm going to give you an assignment, just 2 questions for you to try. If you try it, you can drop your answer on this channel. Okay, you can come back. Like I said, at the end of this live class, a copy of this live class will be made available, so you can still come back and drop your solution. So let us see assignment. solve the following. Solve the following equations. The following equations. So this we have 3 to the power of 2x minus 3 to the power of x plus 2, then equal to 3 to the power of x plus 1, then minus 27. Then the second guy is 2 to the power of 2x minus 3, then dot 2 raised to the power of x plus 2, then plus 32 equal to 0. Good. These are the two questions I'd like you to solve as your assignment. They are simple questions, nothing is there. Nothing is there in the question. Perhaps I could still give you one about exponential. What do you think? Let's see if I can give you one more. Let me see. I want to give you one more. Let me crack it out so that can work on that. Think something of this kind. It's simple. Thing is that I solve a question with the e base. Okay, that's exponential. Question 1, question 2, then question 3. For question number 3, I'd like you to solve exponential 2x minus 6 exponential x plus 8 equal to 0. So these are the 3 questions. Get your values of the unknown x. Okay? Of course, in our next maths class, next week, Monday, I'll be taking you on indicial equation leading to simultaneous equation. I'm going to be fast there. Then there is one form of another question I'm going to solve for you. So I will come to the end of indicial equation. But remember, before next week, Monday, this week on Wednesday, we have chemistry. And on Friday, we have physics. So stay tuned. If you're yet to subscribe to this channel, what is holding you on? What's holding you back? Did you not enjoy this class? Were you not shocked at the way the lesson was being delivered? Things that your friends think that maybe they are difficult before, you see how gradually I broke down the stuff, making you understand that these things are 1 plus 1. There are no two ways about it. Just what you will do for me is make sure as a student that you know your multiplication table at heart, at least from 2 to 9 times table. Then your course term subjects to include math, physics, chemistry, will become simple. Biology is just something you read and memorize stuff. You try to apply them to some, real thing. Look at pictures. That's the pictures of images of, things that are mentioned in biology. If there are organisms, if there are organs and systems, the rest of them. You see, so for those ones that involve calculation, go learn your multiplication table at heart. Am I communicating? So I'll be meeting you on Wednesday. If you're yet to subscribe, like I said, subscribe. Click on that subscription icon right away. Turn on your notification bell after subscribing. And if you click on the notification bell, a menu will pop up. Please select all. By default, YouTube sets down the menu that will pop up, I think, to personalized. If you leave it on personalized alone, you may not get all notifications. So select all so that you can get all notifications from this channel. And this channel does not post anything other than academic work, which most of you, dear friends, need as students. So you should stay tuned to this channel to get all notifications. To do that, subscribe, turn on the notification bell, select all. On Wednesday, we are going to be dealing with how to calculate the oxidation number of a given element in a compound. A topic you really need to understand in order to be able to withstand and learn redox reaction, where you deal with reduction and oxidation. Don't miss out that class. 8 o'clock p.m. on Wednesday. We're coming on live for it. If I don't come up live by 8 o'clock p.m., it could be 8:15 or 8:30, just within. Remember to support this channel, please. Share the video lessons, share the link to your friends, encourage your friends to join this channel and subscribe. You can also go further to give this channel financial support as well too. That would be appreciated. And how can you do that? Send GMAETS 41 super chat or super thanks, or become channel member on platinum or on diamond level. Channel membership is monthly. Super chat or super thanks is a one-time support. For the channel membership, which is monthly membership on platinum or on diamond level, the higher the level you join, the more benefit you get from this channel, because there are certain lessons, video lectures that are specifically made for channel members also, and you can make specific requests if you become a channel member also. Bye. Good night. See you, friends, on Wednesday live.